Welcome back to my video. Today we are going to continue with the rear axle design. We're going to be focusing on the brake system and starting with the suspension layout. And yeah, so let's get started. As I mentioned in previous videos, what I'm trying to do is keep everything as simple as possible. So I am going for a setup that's very similar to a go-kart, where I have a rigid axle with on one side a disc brake and on the other side a sprocket with a motor driving that axle. And in this case I have a dual brake caliper set up in the back because we want to have a hydro e-brake for drifting. So yeah, that's what we're going to be designing in this case, and yeah, with the little space that we have available, we need to see what we can do. Furthermore, what we are trying to do is relocate one of the battery cells so that we have a little bit more space, and we noticed that the space for the disc brake and the sprocket is quite narrow on the inside of the chassis, so we're going to try to put in a little bit more width on the inside, because on one side we are limited by the battery pack and on the other side we are limited by the chassis. That means that if there is some sort of torsion going on in the axle between the left and the right wheel, then yeah, the disc brake or the sprocket might hit the chassis. Now what is important to know is that this car is very low, this car is very light, this car is very small, so we don't need a lot of suspension travel. In a regular road car, family car, you would often see like 100 mil, 120 mil sometimes, and in a little bit more sportier car, we're talking about 60 to 80 mil, and when you go to race car, you're only talking about 40 mil. Now with this car being so light and having so much tire, we are going for yeah, let's say about 40 mil of suspension travel. So we don't need a lot, and we don't get a lot of deformation in the axle, I imagine. So the setup that we have right now should be fine, and it's close, but it should be fine. Since this is quite a long axle, I am going for double bearing on both sides, so that I have at least some support on the outside of the wheel, since this is quite a small axle and quite a big wheel compared to what an axle normally would do. So that's why I added 2 bearings on either side. And for the suspension in the front, I have a push rod setup. For now, at the back I have a spring setup, so with a coilover, but I'm having my options open to go to a coilover, to a push rod setup for that as well, or a cantilever setup, just because otherwise I have to build such a big structure on the outside of the narrow body styles, and I don't really want to do that. And with the cantilever suspension, I can just have a rod popping out on the side of the body panel, if that. And so we are trying to go for that. For the rest, a simple hub. What we're trying to do is have these lock pins in place, and then slide the hub over and locking the hub in place with a big bolt, tightening it onto that lock plates that we have in, or shin plates, I don't know the correct word for it in English. And the same we do for the sprocket and for the disc brake to keep it in place. The disc brake itself is the same as in the front. The caliper for the hydro e-brake is the same as in the front, and the disc brake for the park brake, that will most likely need to be a different type of park brake, because the internals of a park brake are different than a front brake, because park brake is winding itself up, and there's actually a screw in the piston, where a normal front caliper doesn't have the screw function in the piston. What you often see is that on the inside there's like a drum brake setup on these types of cars, but we don't have that. So most likely for the actual park brake I need to figure out something different. But yeah, that is something to do in the next video. So now here at the end of the video we have the trailing arm started up. We have the rear axle almost finished with yeah, with the suspension and the sprocket and the disc brake. And yeah, now we can basically start with the rest of the system around the rear suspension, the engine of the motor mounting, etc., etc. Yeah, so we will continue in another video. Please let me know if you like it. Understand what I'm trying to do here. It's a lightweight build, it's a cheap build, and it's something that I need to be able to make myself. Yeah, so that's basically why I'm going into this direction. Again, I mentioned several times that I want to go drifting with this car, and I know people will say, yeah, you rather not want to have a rigid axle like this. You would want to have independent suspension in the back. I know, but drive shafts and all those things make everything a lot more complicated. And a lot more, I think, also heavier. So at this point in time, we're not going for that. Maybe as an option or an alternative later, but at this point in time, we just want to keep it like it is for now. Yeah, so let's continue on in the next video. Thank you for watching.